All right, day 2. Today we're going to learn a new way to prove two triangles congruent, and that's the SAS postulate. Notice, and we talked about this before, it's side, included angle, side. In other words, the sides are the sides of the angle. We call that an included angle in between the two sides. If your triangle looked like this, and you had this, and you had that, and you had that, that is what we call angle side side, which would spell a bad word, okay? So that is not what we're talking about here. It has to be side, angle, side, in that order where the sides are the sides of the angle. So, proofs. We're going to do some proofs now with our new theorem, statements and reasons. So, we are given BC congruent to DA, and we're given angle CBD congruent to angle ADB. Now, these are all marked. So now, if we're going to use this new theorem, we need side, angle, side, right? We need the other side of that angle, and we can see that that third side is also the same side for both triangles. So I'm going to mark it here. We're going to say BD congruent to BD, just like we did yesterday, reflexive. And then we can say that the two triangles are congruent. BCD congruent to angle DAB, and that is by side, angle, side. So now we have two ways of proving triangles congruent, side, 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 and side, angle, side. Today, though, we are going to focus on side, angle, side. Let's look at this one. One more example. Oh, this is a good one. We have X is the midpoint of AG and NR, and that's all that we're given. And so right now, there's nothing to mark that drawing with. So if X is, let's focus on one at a time. If X is the midpoint of AG, well, that's going to cut that into two congruent pieces. And so we can say AX congruent to GX, and our reason is midpoint divides segment in half. But X is not only the midpoint of AG, it's also the midpoint of NR. And so we can mark these congruent. So we can say NX congruent to RX, and it's the same reason that the midpoint divides the segment in half. So we can put those all together, we can keep those together. Now, we're not done though. We either need a third side or we need the included angle. Well, we don't know anything about the third sides. However, we do know when we have an X, those vertical angles, the angles across from each other on the X, are congruent. So we can say angle AXN congruent to angle GXR, and that is vertical angles congruent. Now we can say triangle ANX congruent to triangle GRX by side, angle, side. Could we use side, angle, side, or side, side, side to prove the triangle's congruent? I recommend you write things side, angle, side, side, angle, side. Yes, SAS. Side, angle, side, angle, side, side. See how those don't match up? So it's no because of that. Those triangles are not the same, and that's not side, angle, side. This one, side, side, side. And this one also, side, side, side. However, we also have these vertical angles as well. So I could put or SAS. It could be either answer. Because if we mark those vertical angles, we could use side angle side as well.